Everyone, my name is Fangming. The goal of my final project is to build 7 different machine learning models to find the one that best predict whether a patient has breast cancer or not. Since nowadays breast cancer is considered to be the most frequently diagnosed life-threatening cancer in women and the leading cause of cancer deaths among women in the world, I think building an efficient model to best predict the result would be very helpful. So the data set I'm going to study to build my model is from the UCI machine learning repository. This data set contains 569 instances and 32 attributes. Features are computed from a digitized image of fine needle aspirate or a breast mass. They describe characters of the cell nuclei present in the image. There are 10 real-valued features are computed for each cell nucleus, including radius, texture, perimeter area, smoothness, compactness, concavity, concave points, symmetry, and fractional dimension. So here I listed all the R packages I used for my project. So first I do for my dataset is to explore the dataset. So the first column is the ID number, which is a useless feature to predict the result. So I set it to null. Then what I do is to detect whether there are missing values inside my dataset. I use the summary function and find there were no missing values inside my dataset. And the next thing is to detect the outliers. So based on the summary report, I think there are 4 features should contain the outlier because the maximum value is very different from the minimum value. For example, like the radius SE, the maximum value is 2.8 and the minimum is 0.1, and you can see the mean are around 0.5, and so I believe this feature would contain the outliers. So after using the box plot to see the outliers, and indeed these 4 features contain outliers, but after removing off all the data from these 4 layers, there are only few data points being left. And in addition, after searching some information online, I believe the outliers contain important information of the tumors, so I decided to just keep them. The next thing, because for my dataset there are 30 features in total, and I believe there will be some correlation inside of between each feature, between different features. So I use the core plot to test the relationship among the features. And based on the correlation plot, we can see that the 1 indicates a strong positive relationship. Negative 1 is the strong positive relationship. And the plot indeed shows there are some correlation within different features. For example, the texture underscore worst has a strong correlation with the texture underscore mean. Therefore, we could use the principal component to decrease the number of the features to use. This one is the PCA, the principal component, the figure, and the y-axis explained the proportion of the variance to be explained by the number of the different numbers of the principal components. And based on the result, we can see that the first two principal components explained around 66% of the variance, and we only need the first 8 principal components to explain more than 95% of the variance, and need only 12 principal components to explain more than 99% of the variance. Therefore, I could use the PCA to decrease the number of features to use. Then I just separated my dataset into the training dataset and the test dataset. I decided to use 80% of my data to be the training dataset and the rest 20% of data to be the testing dataset. The next figure shows how the first 2 principal components separate data. We can see the data are well classified into 2 groups. and the blue color is the M, and the red color is the B, and it also shows that the principal component works very good. And the next two features are just the additional improvements of the principal component. So the next thing is to build a model. So for my project, I used 7 different models, and in order to limit the technical error, I decided to build all 7 models using the Carrot package. Therefore, there will be no errors from using different packages. All the errors will be from the model itself. And the fit control, the parameters inside of the fit control will be applied to all 7 models. So I will use the repeated CV, which is a cross-validation, to test the performance of my model. And I will also use the PCA, center and scale, to pre-process my dataset, and the threshold was being set to 0.99 because based on my previous PCA result, we know that the first 12 principal components will explain over 99% of the data, the variance of the data. So the first model is the KN model, and the second one, and in addition, for my model, for each model I build the ROC curve for each model, and also I show the confusion matrix for the result of each model. So the next one is the GLM, and then continue is the naive Bayes, and so SVM. So there are, and the next one is the neural network. I also use a decision tree and a random forest. So here is the final result. So I compared all 7 models and build the ROC curve for the 7 models. We can see based on the ROC curve, the neural network works the best, and the decision tree and the naive Bayes works not very good, but still good to go. In addition, I used the two models inside for my project. One is the random forest, the other one is the decision tree. The reason I decided to compare these 2 models is because we know that random forest is just a collection of different the decision trees. So random forest is an ensemble model of the decision tree. So we can see based on the ROC result, we can see the ensemble model, which is the random forest, works better than the decision tree. In addition, I also compared the accuracy of each model. Here, I listed the accuracy for the decision tree. The accuracy is 0.1, and the generalized linear model is 0.95, and the KN is 0.96. Based on the accuracy, we can see there are not lots of difference among each model, so the ROC curve reflects the difference better. So my conclusion for my project is after comparing all 7 machine learning models, neural network works the best under the matrix of both accuracy and the ROC curve. But the neural network is not very helpful for the doctors to explain the result because we know it is a black box tools. On the other hand, the decision tree and the random forest is very helpful for the doctors to explain the result. So depend on the requirements. If the doctors want to just only care about the accuracy and for the data, I would suggest the doctor to use the neural network. If the doctors also care about how to explain the result to the patients, I would suggest to use the decision tree or random forest. Decision tree works a little bit worse than the random forest because the random forest is the ensemble model of the decision tree. And In addition, just go back one slide. Here I showed how the model works. How the correlation around each models, like the KNA works very similar to the neural network. The result is very similar to the neural network, and like the naive Bayes shows a strong positive relationship to the neural network. This is also very helpful to compare different models. So at the end, I just want to say that based on the different requirements, we can choose the model we want to use.